When graphing a polynomial, a lot of times you want to concern yourself with the end behavior of the graph. And what that means is what's happening all the way to the left and what's happening all the way to the right of your graph. And a lot of that can be determined by just simply looking at the leading term of your polynomial. So we are going to look at the degree of the polynomial and the sign of the leading coefficient. So all of that is determined by our leading term if we are in standard form, which means our highest exponent is first. So look at the degree, look at the leading coefficient, and then we can determine what's going on at the ends of the graph. So if your graph has odd degree, okay, so the highest exponent is 1 or 3 or 5, if the leading coefficient is positive, so again, odd degree with a positive leading coefficient, your end behavior is down and up. Now again, you could have a lot of things going on in between there, but what that tells us is if we go forever to the left, the graph will be going down, and if we go forever to the right, the graph will be going up. Again, you could be doing a lot of different things in between there. I could be doing something like that. But what the focus is on what's happening at the ends of our graph. Okay. If the leading coefficient, if p has an odd degree again, but the leading coefficient is negative, then we're going to flip this, and the end behavior goes up and down. Again, you could be doing a lot of different things in between there. It could just be a line, but the idea is at the end of the graph, we are going up on this side and down on this side. If the leading coefficient is positive, but you now have an even degree, so x to the second, x to the fourth, if we have an even degree polynomial and the leading coefficient is positive, then our end behavior is up and up. So it could be just as simple as a parabola. Okay, but again, my end behavior is up and up. Again, it could be doing a lot of different things in between. Again, even degree, but negative, that means our end behavior is down and down. So I'm going to give you something that looks slightly different here, but it could be doing something like this, in which case our end behavior is down and down. Okay, so that leading term, both the degree and the coefficient, will help you determine what the polynomial is supposed to be doing as if you go forever to the left and forever to the right. So determine the end behavior of the following functions. I'm just going to check out that leading term, and I have an even degree, it's x to the fourth, but a negative coefficient. So a negative coefficient with an even degree, my end behavior is down and down. So it's going to be going down as far as I go to the left, and as far as I go to the right, I'm going to be going down in both directions. The next one, we have 8x to the third. 8x to the third is an even power with an odd exponent, an odd degree. So a positive, I have a positive coefficient with an odd degree. Okay, so positive coefficient, odd degree, that tells me it's going to be going down on the left and up on the right. So the end behavior is down and up. And I'm going to give you what I think is a quick tip to memorize this. And what I like to think of is with odd degrees, I like to think of lines. So I have just y equals x and y equals negative x here. So y equals x, that is an odd degree. That's x to the first power. So all odd degrees in behavior is this, they work the same way. So I'm just going to think about a line. A line with a positive coefficient, if I put a 1 here, that's a positive value. My end behavior is down on the left, right? If I go forever to the left, it's going down, and forever on the right, it's going up. So my end behavior is down and up. And again, that matches what we just did. But if I just think about a line with a positive slope, I know that it's down on the left and up on the right. Whereas if I think about a line with a negative slope, it's going to be going up on the left and down on the right. Okay, so anytime I think about odd degrees, I just think about lines, and I'm thinking, well, if it's positive in front, it's going to go down and up. If it's negative in front, it's going to go up and down. Just thinking about how lines work. And then with even powers, I just think about parabolas. If I have a positive with an even power, that means I'm going to get like a parabola that would go up and up. Up on the left, up on the right. But if I have a negative in front of my x squared, then it's a parabola that would go down, and I would have down and down. So, you can memorize this table, but if you just think about odd degree, think about lines, and even degree, think about parabolas, hopefully that end behavior will make sense, determining if the leading coefficient is positive or negative to get which graph that would be.